This is our last lesson, and these are the last 2 pages of your handout you printed out. And I'm going to go ahead and label this. This is 9.4, so you know what homework it goes with. And what we're looking in here is testing a hypothesis about a proportion of events of interest in a population. And that symbol is pi rather than the population mean. And what we need to do is get a sample proportion, that is P, and you'll see that in the formula here. The pi again is population proportion, or what we think it is, and we compare the statistic to the hypothesized value of the parameter to make a decision. Here's our formula here. Now we can use our critical value approach or our p-value approach. Now the company claims it receives 8% responses from any mailings. Well, this is a proportion, 8 out of 100. And that's what it's claiming about our population. We'll just write that as a decimal. We want to see if it's different. That's what we're trying to prove. So that will be our alternative. And we do have to take a sample. So a sample of 500 yielded 25 responses. So our little p is going to be 25 out of 500. Okay, so you might want to pause right now and try to write your hypotheses. Now we'll need to use pi, not mu. We're looking at a proportion. And remember, that always has the equal sign. The alternative would be that it is not equal. And when we have this situation, is it a one-tail or two-tail? It is a two-tail when you have the equal and not equal. When's it a one-tail? When you have a greater than or less than in the problem. Secondly, let's pick up some information here. We've got 500 for our sample. Alpha has been set at 0.05 in the problem. We are using the z-stat for proportion. And then let's look at our rejection and non-rejection regions. Again, if it's equal or not equal, it is a two-tail test. Our non-reject is here. Now our tails, what we do is we take the 0.05 and divide by 2, and that gives me an area of 0.025. You can put that there. You can look up the z-score in your table, but we've done this before because if these two together are 0.05, this is 0.95. That's the same as that 95% confidence interval. And so if we have a cheat sheet with these numbers on there, we've already got that. Or like I said, you can look it up by dividing alpha by 2 and looking for that. Now, let's plug in our formula. And let's go ahead and change little p to a decimal. We have 25 over 500, and that's 0.05. Okay, so let's calculate our z-stat and see where it falls. That's 0.05 minus 0.08. All over the square root. That's 0.08 for pi. Then 1 minus 0.08, which is going to be 0.92 if you just want to go ahead and simplify that, over 500. We need to follow our order of operations. You might want to pause and calculate to make sure you put this in the calculator correctly. I'm going to take it to 3 decimal places. negative 2.473. Well, that does fall in the rejection region. Remember, these tails are where we reject. If it's less than the lower value or more than that upper critical value, we reject. And so we reject H of O. Now you can also find P using the calculator I provided in the module. Just use your Z calculator, click on two-tail test, and of course 0.05. And this goes in the calculator. We put what we found for Z-stat, and you should get a P-score of 0.013398, which is low because it's less than 0.05, so HO must go. Okay, the next example starts here. A consulting company conducted a survey with the goal of better understanding the dynamics of product team performance and uncovering the practices that made these teams successful. Having a clear definition of being done is a basic element of successful product management process. One of the survey's findings was that 29.4% of organizations indicated that a collective decision by the product team established this as done. So if you have a collective decision by the team, you're considered done. Now, suppose we get a sample of 100, and 27 of the 100 indicated that a collective decision by the product team was established, and that was going to be this definition of done. Use this significant level to see if there's evidence that the percentage is less than 29.4, okay? They thought it's 29.4, but hey, is it less than? This is what we're trying to prove. This is going to be our alternative, and again, in this case, I like to write my alternative first and then write my null. So for part A, our hypotheses, well, our alternative, and again, we're using pi, is that we think it might be less than 29.4%. We'll change that to a ratio or decimal. So the null has to be, if it's not less than, it must be greater than or equal. So again, in this case, when we have these one tails, I like to do that. Again, this is a one tail because of the inequality. And our tail will be on this side. Now, part B, let's work through this. I'm not going to label all my steps. I'm going to draw what we got here. And our reject will be right here, and that's going to be at 0.05. And Z for 0.05. We had been using negative 1.65 in this homework. I told you earlier in these notes that they are going to use that. And the rest of this is 0.95. Okay, we have N is 100. Little p is 27 out of 100, which is 0.27. And alpha, which we will not divide by 2, is 0.05. Our Z-stat will be 0.27 minus 0.294 all over the square root of 0.27 times 1 minus 0.27. I'm going to go ahead and write 0.73 over 100. You might want to pause, put this in the calculator. I get negative 0.541, which actually is to this side of Z, so it is in the non-reject region, so we will not reject H of O. And if you want to check this, you can go to your P calculator. And P is not low, it is greater than 0.05.